Get started real quick. Appreciate everybody coming to our town hall meeting in reference to the 1.5 cent sales tax vote on June 16th. We have great professionals here. They're going to explain a lot of the history of our water plant and stuff. I only request Mr. Matco, our engineer, is going to speak first. If you could please hold your questions till the professionals have talked and we get all the information, and we'll be happy to take any questions from the crowd. Once again, thank you for coming. Mr. Cook, you're up.
Hi, I'm Matco, Cimarron Valley Engineering. I've been working on the water treatment plant projects that have been under construction for the last little over 2 years now. We've had several projects that we've completed or are currently underway or getting ready to just start. And so we're kind of going to run through kind of a little brief history of the plant, what's been done, what needs to be done, and why we've ultimately ended up at a rehabilitation effort rather than a brand new water treatment plant. If you want to go ahead and go to the next slide. So you can see here, this is the plaque from the front of the water treatment plant. It's dated 1927. So this water treatment plant, we're almost 100 years old. So and it has been modified. There's been several upgrades over the years. There's been some filters added in the 60s and 70s. They've added some additional pumping units in the process. They've changed out some high service pumps out there. And there's been some equipment upgrades over time, but there was a lot of antiquated equipment out there and a lot of structures that are old, but you know, just because the buildings are old and the structures are old doesn't mean that all the bones are brittle. So, you know, anytime you can reduce the amount of concrete that you have to pour around the water treatment plant, you can drastically save cost, you know, extend the functionality of life of a project out. So, you know, obviously after COVID and, well, now currently the war in Iran, it's just been price escalations, you know. So I think originally the city was looking at $12 to $15 million potentially for a water treatment plant. And then all of a sudden inflation hit, prices started going up, and the city of Idaville actually just bid a lime softening treatment plant, brand new water treatment plant facility that was $40 million just this year. So that gets you an idea on what you'd be looking at for approximate cost for a brand new water treatment plant for the city the size of Blackwell. I mean, that's a great example. Okema also just recently bid out a water treatment plant. It wasn't a lime softening plant, but it was a surface water treatment plant. That plant was $36 million, I believe, and it was a 3 million gallon a day plant too. So new water treatment plants, extremely expensive, coupled with the inflation that we've seen due to COVID, and then also pricing drove up too during the last administration with the Infrastructure Acts, because there was so much money that was pumped into the infrastructure that we saw contractors getting loaded up with work. So obviously you saw pricing go through the roof as you know, they had their backlogs built up. And now we're starting to see pricing taper off a little bit, but now with diesel back up, it's kind of tapered off. But at least the contractors are kind of getting hungry again. We're seeing some competitive bids because a lot of the grant money has dried off. And so a lot of the projects that are hitting the streets now are just the very last little bit of the ARPA funds that were left. And most of the projects are either financed through an Oklahoma Water Resources Board loan, such as a financial assurance program or a drinking water state revolving fund. Even those programs that did have some incentives, such as principal forgiveness, have drastically cut the amount of principal forgiveness available due to EPA funding cuts that don't get passed through the Oklahoma Water Resources Board anymore. Next slide, please. So, why do we need improvements? Well, I mean, the picture in the background here kind of tells you this was before we had done any projects. As you can see, we have some pumps sitting outside, extension cords laying through standing water. We just have antiquated pumping systems, and aging electrical system. We've got filters that are in critical condition. There's limited redundancy in piping. And then we had some disinfection byproduct concerns in the storage tank. The city has not had to send out a lot of notices, but in the past they did have to send out notices for disinfection byproducts. There's a lot of water systems in Oklahoma that have been dealing with the disinfection byproduct rule, which is one of the newer rules that EPA came out. So those are primary drinking water standards that were recently regulated by the EPA that they form when you add chlorine with water, particularly surface water. It reacts with carbon, and it forms these trihalometane species of disinfection byproducts and HA5 acids. And so you have to kind of change your treatment process to target carbon removal and things like that. The city had done some stuff in the past, such as add a carbon dioxide feed system to help remove some of those precursors that form DBP products. And we recently did some projects at the plant too to help reduce the DBP products. And I don't believe we've had to send out a notice for DBP products in Roman. When was the last time we exceeded our DBP product exceedances? It's been several years, hasn't it? Yeah, so, and that was part of the reason we got a grant, was because we had violations for disinfection byproducts, and one of the first projects we did targeted that. Next slide, please. So this is an overview of the site of the water treatment plant, and I just created this just to kind of show you what we have either completed or have under construction today or just awarded, okay? So if let's start at the bottom, the sedimentation basin rehab. Right now, the equipment for the sedimentation basin just came in. It's a chain and flight system that scrapes the bottom and removes the settled solids from the treatment process. When you add the lime to the water, you're settling out the calcium carbonate hardness. It goes to the bottom, produces a lot of solids. So those scrapers have been in service for 40 or 50 years. Those have been replaced. We just did brand new concrete walkways across those basins, and they're going to start installing those equipment by the end of next week. We just got our first concrete breaks today, and we got 4,000 backslide at least. Yeah, 4,000 PSI breaks on that. Just above that, that's a lime feed. That's one of the most important chemical feed systems in the water treatment plant. You know, that's what we add to the water to raise the pH. Settles out it settles out calcium carbonate hardness, and it also removes iron and manganese from the water when you go at such a high pH. And lime, what it also does, it will remove radium, which when we first started looking at water quality, it was discovered that there was radium in water because we need to make sure that we could, you know, what were some options for removing radium, or do we go back to lime feed? Ultimately, lime feed was selected to stay with lime feed because it softens the water, provides a higher quality drinking water, and you remove iron, manganese, and it just targeted all the primary and secondary water quality concerns that we have, which is hardness, iron, manganese, and then radium. Nobody wants to drink water with radium in it. You know, you won't glow at night, but it certainly isn't good to put radioactive substances in your body. But lime absorbs it, settles out. So that was that. The carbon dioxide feed system, that's what we use to form carboxyl acid to add back into the water. After we ramp the water up to a pH of 10 or 11, we feed that in to bring that pH down to about an 8 before we go through our filters. Okay, so we raise the pH, all the iron manganese settles out, the calcium carbonate settles out in the settling basins, and we bring it back down. And that one was just bid out and awarded at the last council meeting. The transfer pumps and electrical upgrades, we overhauled. We put 3 new transfer pumps in right there, a 3 million gallon a day pump and 2 1.5 million gallon a day pumps that basically transferred the filtered water to the 2 big storage tanks at the north part of the water treatment plant. Those are pretty critical for getting water from the clear well to the ground storage tanks, and ultimately the pumps that pump it out to distribution. All that electrical has been redone. The transformers have been changed out on the building. The switch gear has been changed out, VFDs. And then we totally rehab the 2.5 million gallons of ground storage area over there. New paint jobs on the tanks, and then we put in an aeration system. Now what the aeration system does, it turns the tank over constantly. We put spray nozzles up top that basically make fine droplets. You know, we turn those tanks over once a day, and as those droplets form and fall back through, it removes some of those disinfection byproducts if they do form in the treatment process, and it further helps reduce the constituents and concerns that we have had problems with in the past. It also prevents stratification of water in the tank because you're constantly turning it over, because in the winter time what happens is the upper levels of your tanks freeze and you'll get ice formation in your tanks, but when you're able to constantly keep them turned over, the water quality improves drastically. So that's what we've touched in the plant so far. We have not touched the process that we handle solids. We have not touched the filters yet. Actually, we did put some valves in so we could isolate the filters and prepare ourselves to be able to take 2 filters offline at a time, or in the event we had a catastrophic failure in our filter gallery, we could isolate it, keep 2 filters online to make sure that we didn't lose the capability of providing water. We've also provided backup power at the water treatment plant, so we now have the capability to pump water to distribution in the event of a prolonged power outage. There's generators that are powering the high service pumps that pump the water from the tanks to the system, and there's also a generator in place to keep the water treatment plant online. Those projects are about ready for final inspection. We're waiting for 2 new transformers, and once those transformers are set, that generator project is complete. Next slide, please. So, the first project we did was funded through the CDBG. We got a $600,000 grant to begin with, and then we went back to Commerce after we got bids, and we got an additional $1 million, I believe, on that. So we got $1.6 million to go to this $3.2 million project, and that was the electrical modernizations at the high service pump station, where we replaced those pumps, and we painted the ground storage tank and put in the aeration system I discussed. And you can see kind of the workers in there working on the paint job in the tank there. Next slide, please. So this is that aeration pump system in there. 2 pumps are dedicated to each tank. 1 pump is for redundancy. So those pumps will run, they're on VFD, so they'll ramp up and down just depending on tank level to maintain a discharge pressure and make sure we're turning those tanks over adequately and constantly keeping those water moving in those 2 ground storage tanks. You can see a nice blue paint job on the tanks now, so the painters did a really nice job on it. Got a good mill thickness on the tank, so I was glad we got that done when we did, because paint prices have gone up drastically with fuel prices. Next slide. Up top here, you can kind of see the piping up there on the top of the tank. That's that aeration system I was talking about. You can see there's 5 nozzles in that big tank right there. And so it's just like a big cone. When they spray, it hits this nozzle, it causes the water to go out, and causes it to drip, fall down, and that's what atomicizes the VOCs in the water, the trihalomethanes. Then you can see there, you remember the first slide, you saw the picture of the pumps with the electrical cords and water standing and all that, and half pumps and rough. Well, that's your new pumps right there on the outside. So quite a big upgrade, and a safety upgrade as well too. I mean, you had guys out there having to work on stuff standing in the water, so this enhances operator safety and certainly the reliability of the water treatment plant. Next slide. This is just another before and after photograph of the same thing. So. Then there on the right, you can see some of the old electric panels, and then on the left there, you've got new VFDs, new switch gears, new main distribution panels, things like that have been put in there. And there's also now a generator that feeds this facility as well too. So our high service pumps are still old, but we have some plans for being able to upgrade our high service pump capabilities. So we're set up now anyway on the electrical side. So, and these pumps have been in service for quite some time. But putting them on a VFD, make sure they're not on a cross-line start. VFD makes it real, because you can start your pumps gradually and easily. It's not just a jolt. Whereas you just, if you have cross-line starters on your pumps, you just hit it hard, and eventually it wears out harder on the bearings and things like that. So nice to have the VFDs in place. Plus it reduces the size of generator you're required to handle the full load amps when you start these big motors. So this is the lime slaker, or slacker, just depending on what part of the state you're from. So the lime slaker, they were kind of slacking a little bit. They were about ready to slack off. You can say, I didn't want to sneeze near him, because I was afraid it was, it looks like it was on the verge of needing some duct tape and baling wire to hold these things together. They had been in service for quite some time. So what they do is the silos above them feed lime down into these slakers, and it mixes with water, and it turns it, and you react the lime. And it puts off a lot of heat while that reaction is taking place. But once it's activated, then you put it out there in the water, and that's what provides our reaction that we need to soften the water. And it has the other benefits that I mentioned, like removing the radium from the water, making the water softer, and getting iron and manganese out of the water. Because a lot of times iron and manganese is what will give you the water that looks like it's iced tea. Now there's other issues out in the system that can do that too, like high flows in pipes that are 100 years old too. So sometimes people see that setting and get kicked up in the system. Well, that's just because it's cast iron mains that have been in service for 60 or 70 years. And if you get a fire or a big line break that disturbs that stuff, it can kick up sediment, and it takes a while for it to clear off. It doesn't look good, but that's just part of, lots of cities that have aging infrastructure have those. And the city hasn't put in 5 miles of line using city forces over the course of the last 5 years. So that's and that has been a considerable saving to the city to be able to have a public works staff that is capable of going out and doing work of this magnitude without having to contract it out. So this lime slakers and set basin. So we changed out the lime slakers and set basin. This was a $2.6 million project that is underway. Actually, that project bumped up to $2.9 million because when we got the basins down and we got inside there and started looking at the bottom side of the walkways going across the basins, we had some money in the budget for rehabilitation of concrete surfaces. But when we got up under there and we started looking at the concrete pad, we're going to try to chip, hammer, and put some bonding agent and repair the bottom of it. When we got in there and started looking at the condition of the reinforcement on those walkways, we decided that we better replace the walkways because the rebar was basically gone in some places. So we poured new walkways on one side. We'll pour the other side once we get the equipment on the new one. Next slide. So on the left there, you can see the new lime slaker units compared to what we had on the right there. So completely stainless steel. You got vibrators to help shake the lime down. Very efficient process. Will reduce the amount of lime they have to feed to hit their pH because the efficiency in which you mix your lime up has a big effect on how much lime you have to feed to hit your pH. So these are set to where they get the exothermic process perfect to get this lime reacted before they add it into their flash mix to mix it in with the water. So that should reduce operating costs by more optimization of the chemical feed process. So and we have 2 units, so we have full redundancy in our lime slaker units now. We did manage to get a $150,000 grant too to pay for part of one of these lime slakers as well too. Next slide, please. Electrical panels there, you can see the ones down there at the bottom right, those are all new electrical panels compared to the ones on the left. lot better NEMA rating on these panels than what we had before. The other ones looked a little scary after being in a lime environment, so high pH for so long. So that was nice to get that upgraded. And then also we have, that's basically the panel that serves a lot of the components once inside the treatment process itself. The chain of flight systems, the rapid mixers, the line feeder. So this is a major electrical load center in the water treatment plant that now has a generator on it. Next slide. These are the sedimentation basins. So on the left, you can see the chains and sprockets there, and they pull these big longitudinal arms across the bottom of the basins that pulls all the solids, the lime residuals that settle out in the process. And you can kind of see on the right there, you can see where the little white cloud is in the water right there. That's the flock. So by the time it goes across this rectangular basin, it just gradually dissipates and settles out in the basin, so we're not overloading our filters with solids. And that's the purpose of the sedimentation basins. So that's, next slide please. So here you go, you can see on the bottom left there, you can see where there used to be rebar, nice brown color there, where it's kind of rotted away. So those are the walkways that have been cut out, one has been replaced. I didn't have new pictures of the new ones there, but anybody that would like to go see new concrete or walk around the plant, we are doing tours every Friday to let people view some of the work that's going on, and some of the things that have been done at the water treatment plant, and kind of grasp what we're accomplishing here. Next slide, please. This was an insertion valve project. Now this was part of the deal to be able to isolate filters 1 and 2 and filters 3 and 4. This was to set us up to be able to rehabilitate filters, or if we did have a catastrophic failure in the filter galleries, the ability to isolate it, to get down there and repair it, bring it online while keeping other filters in service. So we cut in some valves. This was a $250,000 project to buy some insurance and accommodate a smoother construction project for a later phase that's coming. That's what the sales tax is hoping to fund, is basically the filter upgrades and several other improvements we'll talk about shortly. But this was instrumental in getting us set up to be able to handle that. Next slide. SCADA system modernization. So, it's kind of, I don't know, everybody's seen The Wizard of Oz, where you got the guys in the back pulling the chains, spinning wheels, doing all that. So, the operators running around having to run everything by hand and not really able to monitor things efficiently. So we are putting in new instrumentation throughout the plant, so they have monitors on equipment to let them know, hey, we've got a fault of this motor, we need to go see what's overheating, allow them to understand if there's a hiccup in the process without having to physically go around and actually witness something going bad or smoke coming from something. So it's just going to be a system-wide SCADA. It shows them what pumps are running, what water quality parameters are going, what the filters are doing, if there's a backwash, what the tank levels are doing, and it just provides and it keeps record of data, which helps to report to DEQ, hey, here's our filter turbidity, here's the things that DEQ wants to see when they come in and say, show us your records. So it's a valuable tool that they needed desperately, and this one is currently under construction. And as new systems are coming online, the integrator is bringing those systems online to integrate it onto the new water treatment plant data acquisition center and control system. Next slide, please. The generators. Well, if you can't treat the water because the power's out, then that's a problem. The city did have an old diesel pump that was hooked up to the clear well. So if they could go out there and they could get the diesel pump started, they were able to pump water out of storage for a while, but it was kind of a temperamental, what was that diesel engine that was down there? It was, do you remember what brand it was? Is it old Caterpillar?
Old Cat, yeah.
Is it old Cat? Probably 60s?
Yeah.
60s small Cat, down in the basement, you'd go out there and hit it just right, and maybe it'd start up, and once you got it going, you were in good shape. But trying to get it started, especially when it's freezing cold out, and typically when things go bad, was a problem. So now that we have a generator out there, we'll be able to keep our pumps going. And then also we have the generator at the main plant, which allows us to keep producing water, even if we have a catastrophic failure on the electric system, or a big storm comes through, knocks power lines out throughout town, or whatever else, transformers, blows up. So we'll be able to keep producing water. So big improvement to prevent major disruptions in water service. Next slide. The carbon dioxide feed improvements, this is one we just received bids on and has awarded. So that carbon dioxide feed system that we have out there now is going on, it's a little over 20 years old, and it just, it was time to be upgraded and replaced. So we're going back with a similar system. It's a Tomco system, very reputable manufacturer. They handle most of the carbonic acid feed systems at lime treatment plants. I mean, all it does is take carbon dioxide, mix it with water, it forms carbonic acid. It goes out there into a reaction basin, and then we keep a pH probe in there, and we feed until we hit our target pH. It's really not a complex system, but that's the gist of what that does. And that one they're pulling their bonds insurance right now, and we'll be having a kickoff meeting for that one probably within the next 3 weeks. Next slide. All right, money. So here's what's been, this is what's been spent, or what is in process right now. So you can see the CDPG high service pump station, that is done. $3.2 million project that received $1.6 million in grant funding. Lime slakers and set basins, $2.9 million with a $150,000 REAP grant that was obtained. The insertion valves of $258,000, SCADA system, and at the bottom there you see $9 million with $2.5 million of grants that we've been able to secure to go towards this project and lessen the financial burden on this. Next slide. So what do we need to do still yet? Well, filter improvements. We need to upgrade our filters. Our filters, 2 of them were built in the early 1900s, and 2 of them were built in the 1950s. I think 1950s. Yeah, Blackwell Beach plants from 1950. And what's funny is, well, it's not funny, but what's interesting is if you go and you look at the 1920s filters compared to the 50s filters, what side you running, Roman? What filters you running? The 1920 ones. The piping from the 1920 filters is better than the piping in the 1950s filters. The ones over there, the 1950s filters, make me a little nervous. I mean, the piping on the other side there, it's still old, but we've got some pictures we'll look at here in a moment to get you an idea on what's down there. I will not be taking people down into the filter gallery on tours, I promise that. Residuals management improvements, so that's how we handle. Lime produces a lot of solids. The good thing about the lime is it's an agricultural product. It can be used in an agricultural purpose. The city has an ag vendor license, and you can go out there, put it on your field, adjust your soil pH, and utilize this for agricultural purposes. So it's not a horrible byproduct that you have to dispose of at a landfill. It's not like biosolids that you're hearing now with the PFAS contamination and things like that. This is a beneficial waste product produced from the treatment process that can be used to support local agricultural industry in the area. So, but some of the equipment is old, failing, in need of replacement. It's going on 25 years old now. I believe it was constructed in 2009? Yeah, no, it was a little bit earlier than that. 2009 is when, it was early 2008. Huh? 2008. 2008? Okay. So, it's getting pretty old for something that handles lime. Lime is a very abrasive, lime residuals are very abrasive and a very high pH, and so the equipment you utilize to dewater it has to be built right. I mean, it has to be designed for that pH environment, for that abrasive environment. They got very long life out of their vacuum presses, which basically use a vacuum to pull water out of the solids, and then it would fall down to the trucks. But those units are basically beyond repair now and need to be replaced. For the meantime, I got the city with a company that makes these geotubes, and we've been pumping to these geotubes, which retains the solids, keeps the rainwater from getting back on them, and so they just pump over to them, they fill up, and then once the bag's full, we can cut them open, load them up with the front end loader, they're dewatered, dry, and haul them off site. Not great for a long-term solution, but for the short term, until we can get some equipment in place that's working good, you know, they've got a lay-down area that's large enough they can contain the water that comes off of it and get it to back to the sewer collection system. So it's bought us some time on that, but it's certainly not it's a great backup, but not a permanent solution. Next slide. You know, DEQ has some findings. Obviously, we've got a filter gallery that's very old. It floods during backwash. We can't backwash the filters long enough because there's a tank that got put in the 90s. I believe the 90s. And it's underground. So all that backwash water was supposed to go to that tank, and then it goes out to a lift station. We pump it up there to where we settle out our solids to go feed our dewatering equipment. Well, over time, that basin underground has lost capacity, and there's just not a good way to keep that cleaned out. So now when we do filter backwashes, it starts backing up into that filter gallery, which is part of the reason we don't have electric actuated valves in the basement. They're using hydraulically actuated valves because that's a little bit better than electric actuated valves when it does have water. But that's a problem for obviously being able to backwash for the full 15 minutes that DEQ wants. We don't have flow meters down there on the existing piping. That's something that wasn't required when these were there. The loss of head gauges, there are actually some old Venturi meters down there that were used for that could measure flow rate and loss of head across there, but they're not in a condition where we could accurately read the pressure and flow across those meters anymore. Those aren't used anymore. Typically now you see insertion meters or magnetic flow meters rather than the old pressure differential devices that we utilize to measure flow rate. We don't have a filter to waste capability, so now after you backwash a filter, DEQ requires you to waste water from the bottom of that filter for a while. So they want to see you backwash it, and then while you're letting all the sand and the anthracite that's within the filter, you know, it stirs it up, kicks up, and they want to have it settle back down, reconsolidate for a while, and then return the filter to service. That's something that came along later on with EPA rules, with the enhanced surface water treatment rule, that the plant just was not equipped to handle that. And then we don't have a backwash flow meter. So these were all things that DEQ came out and said, you need these things. Yes, we do, but we also need the funding to pay for these things. Next slide, please. So this is on the 1950 side. So this is nice dresser coupling right here. As you can see by the bolts on there, it's doesn't look good, does it? No, it doesn't take an engineer to look at that and tell you that doesn't look right. So next slide, please. These are some of the old valves on the 1920 side. Some of the old rate of flow controls, and you can see right there the Venturi meter in between the two, but pretty old. Time for some upgrades. Next slide. This is this was a video. This was a video. I have a flash drive. If we want to watch a video of the walkthrough, just let me know, and I'm happy to load it up from my flash drive. Everybody wants to see what the entire filter gallery looks like. Next slide, please. You can see where we're having to, that's your sampling point there. That's a chlorine. That's your chlorine injection point right there, leaving the filters right there. But you can see kind of the old lead solder joints right there where they put the oakum in the joints on that particular style of pipe right there, and then they come in with lead soldered in place right there. So we don't do that anymore. Next slide. So I looked at, we could rehab those filters. The concrete is good shape. Got them, put piping in there, go in there, put new under drains in, but at the end of the day, that would have been very labor intensive, very costly, would have took the contractor a lot of time and effort to do that, whereas we could get a pre-engineered unit, as this background here, and bring it in on a truck. And that's a 3-filter cell system that can provide 3 million gallons a day of filtration capacity, that we could come and set in, construct it, get it all hooked up without having to interrupt or take a chance of catastrophe occurring while we're down there messing around with the filter gallery. So this was a major savings to the overall project cost, just a value engineering. So these filters will meet all DEQ standards. They have air scour and backwash system. They have all the flow meters, turbidity meters. Basically we would construct a concrete substructure to set these in to house the piping and the control valves, and then have the pumps and the blowers and everything situated. But much major saving on construction costs, as opposed to trying to rehabilitate these filters from the 1950s or the 1920s. All that piping is below concrete in the ground, difficult to get to, a lot of demo work just to get the old stuff out, to go in there and have to demo stuff out to get the new stuff in. So that's where we decided we'll just go with new filters. Next slide. So this is sitting on the left there, that's the set basins. The 2 square basins you see right there in the lighter color, kind of directly north of where the line D call out is, that's filters 3 and 4, and then that's kind of how new filters would be situated in there. Then you can see the backwash pump station to pump not only backwash water from the filters, but also the blow downs from the set basins where the lime particles settle out. So next slide. This is just a plain view kind of the filter gallery, how you would arrange the piping, effluent water from the filter, from the bottom of the filter cells, and then you have wash water that would come in to backwash there, and then you have waste line to be able to go there. So basically each filter would have 6 different valves to control air, backwash water, influent water coming in, waste, and then the backwash wastewater and filter effluent. Next slide, please. Residuals handling. This is a gravity thickener, so everything that gets pumped out from the set basins and the filter backwashes goes up to another clarifier. Now what this does, it is to let particles settle out so we can retain the particles, be able to dewater and dispose of them properly, and then the clear water can either be recycled back to the head of the plant or it can be sent to the wastewater system. Either way is acceptable by DEQ. They'll let you recycle up to 10% of your influent flow, and that's what you see in a lot of these, but ours is so hydraulically overloaded right now because we've lost the storage capacity in our basins down low that we have to pump too high, so we get a lot of carryover through those 2 concrete lined pits. On the background, you can see kind of behind that drive there are those 2 concrete pits. So all that water goes out there, and then we have to dredge those out twice a year to keep those pits clean. And that, what was that last cost of having to dredge those out? $34,000 every time. We have to do that twice a year. So we don't want to do that anymore. We want to improve that. We want to kill that $74,000 operational cost at the water treatment plant by improving efficiencies, which is a considerable saving. So how we do that is we attenuate flows coming to the gravity thickener to where they don't have to pump it so hard. We need a nice holding basin to hold that, keep everything mixed up in suspension, and feed it nice and slow to where we get, instead of rather just a big surge of flow all at once, and then wait for the next one. Now we take that big surge of flow, we put it in a holding basin, keep everything mixed up, then send it to the gravity thickener and let everything settle out nice and slow and prevent the carryover of solids. Next slide. So those are those two lagoons that they have to dredge out. We're going to retrofit one of those. That was another value engineering idea we came with, because we're looking at possibly doing a mixing basin. And I said, we don't need it. We have these concrete lined cells out here. Let's go out here and put some equipment in this existing concrete, and we can keep these mixed up, and then we can pump from there to our gravity thickener, and that's a major savings because we're not building a brand new concrete basin. We're utilizing the existing concrete lined pits that are on site and reducing the amount of concrete we have to pour on the side. So we'll send filter backwash there, we'll send the residual basins flow down there, and then we'll have little motor pumps with jets that basically just keep it all churned up, and then we'll have smaller pumps that pump out of there, just slow and continuously to the gravity thickener, and that's the way the gravity thickener truly likes to operate. And that's going to prevent that carryover of solids and that additional 75 dredge these pits out. Next slide, please. Residuals lagoon pump station. The concrete's in pretty good shape, but we need to change out that control panel, put some new pumps in there, and then you can see on the left there the pit that we're going to retrofit. It's already got a nice walkway out there. It's going to take a little bit of modifications and retro, and without having to go build a brand new basin. So, next slide. There you can see the line down there in the bottom. That's where you want it to go. You want the line to go down there at the bottom, and then we pull it out with pumps, and we pump it to our dewatering device. That's what's going to those tubes that I was talking about now, but before we would pump them to a vacuum press, and then we had a bay where you could park a truck underneath and drop the stuff directly on the truck rather than having to handle it, whereas right now we pump it over to the tubes. We have to cut the tubes open. We have to get a front end loader. We have to get a truck and do that. Once we can get that system back in place, park the truck under it, truck gets full, haul to where we need to stockpile, store it until it can be utilized for beneficial use. Next slide. That's a vacuum press right there. It doesn't have the cloth media on it anymore, but there's a big vacuum pump back there that pulls suction on these units, so when you put the solids in there, it sucks the water out of it, and it leaves the solids on the inside. They rotate, and then it drops out the bottom into the truck loading area, and those are not functioning currently. Next slide. This is what we're looking at potentially, was doing a new basin with jet mixing, but that was before I said reutilize those old basins that we had to save money, that concrete there. So we did that, and then we were able to locate those pumps in the basin. We get to build a much smaller pump station and manage to save some additional project cost off this plant. So because we need to spend, money wisely to get as far down the road as we can, but also set this thing up to where it can be utilized in the future. That way we're not having to build a new plant, we're just replacing components if we need to in the future. Save cost and not have to build a $40 million plant. Next slide. Talked about restoring the vacuum presses already. Adding polymer to the gravity thickener, all that does is enhance settling. Basically causes a big fish net. You have polymer and water, it expands, start catching particles, and just falls like a big fish net through the water, and as it gains more mass, it enhances settling within there. And then adding polymer to the vacuum press to further enhance the dewatering capability of that equipment. Next slide. Other plant improvements, obviously get some chemical feed systems back up to date. They've got some room there by the main office there that we can do some spill containment and storage for chemicals. They already have a pretty good little storage building out there for their chlorine box. You have to store that in a separate building. They have a pretty good building that they store their chlorine gas cylinders in right now. So it's in a safe, fairly secure. I'm not a fan of having the 1-ton gas cylinders in town, but ultimately we may be able to transition to a bleach system and try to do something there in the future. But that's lower on the priority list right now. There's a lot of communities that rely on chlorine gas systems to provide water, or to provide disinfection of the water. So it is certainly an acceptable technology. It's just you don't want to breathe in chlorine gas. Obviously, it's dangerous. We have a hazard response plan that the fire chief has and the operators have in the event there was a rupture or something happened with the chlorine gas cylinder. Piping improvements, dedicated fill line and ground storage tanks. There's some just yard piping that needs to be done as well too. Next slide. This is where the $14 million comes in. This is kind of the breakdown of the various components that still need to be done. The filters, the waste handling system, the solids handling systems, everything to take care of the backwash waters, chemical feed improvements, rehabbing the gravity thickener, and just the things that really need to happen to give us, essentially a new plant in an old plant without having to spend the $40 million. Next slide. So this is kind of a summary of improvements. Once all this is done, flash mix, line feed, sedimentation, pH control, filtration, the residuals handling, disinfection, pumping, electrical systems, control system, finished water storage, and disinfection byproduct control. Okay, if I was going to build a new plant, that's everything that a new plant would have. Okay? We're rehabbing a plant, and there's not one, it's just, there's nothing I would do different for comparing this rehab job to a new water treatment plant job. The only difference is the amount of money it takes to do it. Next slide. So, at the end of the day, this is where we project we're going to be. Total project cost, we're looking at around $23 million, and we hope that with the grants that we've had, that's right at about $20 million, which is about half the cost of what a new water treatment plant would be today. That will get us down the road, and that gives us flexibility to address things in the future and fix a set basin, fix a structure rather than all at once. Have to do everything now, and this gets us down the road for many years. As long as the equipment is maintained, you've got equipment that should last 15 to 20 years. You can replace mechanical stuff. Keep an eye on your concrete, catch it early. You can take care of concrete as long as you call your engineer and say, hey, we've got an issue here, and we can go in there and we can repair stuff. It's a heck of a lot cheaper to repair things right now than it is to construct brand new. Drop another slide, or is that the end of it? I think that's the end of it. I'm glad to answer any questions or hear comments, concerns. Open this up for discussion. That's it. We covered a lot. I'm happy to talk about any of the processes. Anything on the project.
What kind of maintenance program you got on this?
Every piece of equipment we get an O&M manual that tells you, what to do. And Roman keeps a manual at the plant there to make sure that he's greasing stuff. And that's one thing that Blackwell has been good at, is taking care of equipment, because if they weren't, we wouldn't have equipment out there that's 50 years old and still in service.
You know, they have been able to repair stuff in-house, keep systems going. So, you know, I don't go into that plant and see guys twiddling their thumbs like I do some places. I go in there and it's got to be just a major disaster before they say, "What we do now, Matt?" You know, I don't have that issue here. It's, "Hey, Matt, this doesn't seem right," and then we can get on the phone, get online on the phone with manufacturers, you know, because we've had to work through some hiccups just on bringing new systems online, just to get things dialed in right. But no, we've got a good staff at the water treatment plant, and Public Works as a whole in the city accomplishes a lot compared to other cities I work in. I mean, 5 miles of water line with city staff, and then you got a road crew out there paving roads, you know, and you got a water treatment plant that's keeping a water plant making water that's 100 years old. Now I know, you know, water quality in the system will improve as new pipe gets put in the ground. I mean, you've got a line plant that's been in service for 100 years. There's going to be a lot of scale and buildup in those pipes over time, and that's corrected through, you know, creating stable finished water, because to prevent kicking up the stuff that's built up on the pipe, the tuberculosis or what, I can't even say it right, but the stuff that builds up on the insides of the pipes, okay? But now you go out there and you start flushing hydrants, it's going to create some dirty water because you've had scaling on those pipes for 60, 70 years, and some of that breaks loose. You know, it's not dangerous. It's not. It's just not convenient, and it's not good on appliances. You know, but as far as meeting primary drinking water standards, the city has done that. Otherwise, they'd be sending out public notices every other billing cycle to say, "Hey, we had an exceedance for this, that, or the other," and you know, I mean, they found out they had radium in the source water periodically, and that's never come out because the water treatment plant has been set up to remove the dangerous substances. It's hard water. It's hard water, and there's a lot of scale and old pipes in the system. So as we keep chipping away at that and spending less money on the water treatment plant, not having to put $40 million on that certainly frees up financial capabilities to keep it addressing the other infrastructure needs the city has, because it's just not a water plant. They have to take care of their wastewater plant. They have a great wastewater treatment plant, but it's been in service for a while now, and it's going to start needing a little TLC and replacing some equipment, and you know, eventually. And so, and I mean, what's the population of Blackwell done over the past 20 years? It hadn't really grown. You know, it's not, so it's hard. It makes it harder for a community that maybe is slightly on a decline right now. And I think we may see some population growth because Oklahoma as a whole is starting to finally see some population growth. We seem to be we seem to be having some people moving in from the west and east coast into the you know, Central America, got Texas and Oklahoma, so. So it's tough to, especially with price increases, it makes it really difficult for communities to sustain their infrastructure with rising cost and a customer base that is either just basically stays the same, you know, because nobody wants to hear rate increase, and I don't want to have to, you know, I want to get this done for, you know, the best price we can, so you know, we can address the other issues in the infrastructure too and stretch the city's dollars as far as we can go. I mean, that's my objective. And, I mean, I don't know what else? Anybody's got more questions?
Thanks, Matt. I feel the same way when the engineer talks too, so don't feel bad.
I like a captive audience.
I feel like I just left Stan Gable's biology class. Thank you, Matt. First and foremost, can't thank Matt enough. Those grants you saw on there, Matt Coe, Bryce Kennedy, and Russ Meacham, big players and getting those grants. That's a lot of free money that they've helped us get that we just can't say thank you enough. And working with Matt and his engineering company, and you kind of hear Matt talk about it, he goes above and beyond to try to find the best, cheapest way to stretch the dollars here in Blackwell. So Matt and Cimarron Valley, we can't thank you enough. Let's talk real quick how we got here. Where did the 1.5 cent sales tax come from? Well, the city of Blackwell passed it in 1999. In 1999, when the voters passed that, it was supposed to go, well, it wasn't supposed to, it went to parks, the pool, all your recreational stuff, which is great. Then in 2005, Blackwell passed ordinance number 2753, extending the 1.5 cent sales tax to September 30th of 2030. And that's when they included infrastructure pieces, electrical, sewer, and water on that. So I'll give you some examples of what this 1.5 cent sales tax is paid for. In 2006, $7.7 million for CO2 systems and a 1.5 mg water tank repainting. The Brahms sewer pump station and pump upgrades. In 2008, $2.3 million, various electrical conversions, west side service area water improvements, which would be majority on the west side of town. 2012, $5 million for, this was the Coolidge Street project. They redid Coolidge, they redid all the water lines, all that over there, all the drainage and stuff. And they did 4.5 miles of water line during that project. So that's what a lot of this 1.5 cent sales taxes went to. Now, I know we live in a time, the economic times we live in, people are like, well, I don't want to pay no more. Okay, I totally agree with that. There's a lot on the ballot June 16th that has to do with taxes and stuff. And that's totally understandable. But this is one funding mechanism that the city of Blackwell, we're already paying the 1.5 cent sales tax. The city of Blackwell has been paying this since 1999. So if I'm driving down the interstate and I don't live here and I get off the interstate and I fill up with gas and I come eat at Giovanni's because to me it's the best pizza in north central Oklahoma, the sales tax I paid, 1.5 cents, that goes to the city and I don't even live here. So those are the reasons this is the first proposal to the council. And the other thing I want to hit on, when I took this job 5 years ago, I often find myself asking the question, how did we get here? I grew up here, you know. How did we get here with a water plant built in 1927? And I come to the realization, because the life I've lived, it doesn't matter how we got here. The mayor sitting here, the councilmen and councilwomen sitting here, they weren't part of all this back in 27. They weren't part of this 30 years ago. They weren't part of this 20 years ago. So we could pose the question to a lot of people in the past of how did we get here? Why wasn't this done years ago? But I always land on the analogy, it doesn't matter. It's our job to move it forward, to fix it. Because I always tell the mayor and the council, if one of three things fail, the government has failed this town. That's sewer, water, electric. If one of those three things fail, the government's failed. That's their priority responsibility to make sure all citizens in Blackwell have those three things at a minimum. I can drive around a pothole. I can put one cop on the street. You know, we can go on foot patrol. There's a lot of things you can dumb down, but if one of those three things fail, then the government has failed. So this council, they're handed this problem, and it's up to us to find a solution and a way to fix it and get it absolutely completed for the city of Blackwell. So I would be happy to take any questions on how we got here while we're proposing the 1.5 cent sales tax. Now, if it fails, we'll bring it back to the council. That'll do my job. If the vote fails on June 16th, it's my responsibility to bring that back to them to see where the road goes from after that. But right now, given the history of Blackwell, we've paid this since 1999, it's the best way to acquire debt service to finish this water plant. I'd be happy to take any questions. Or do we need a break after the engineer call? Outstanding, by the way, Matt.
How much longer is it going to increase? How many more years?
It'll take us to 2041. Yeah, right now it expires in 2030. All we're asking for is to extend that out to 2041, is what it'll do.
And that cover the amount we need?
Yes, ma'am. Now, a lot of people in, the recent few days, and I get it, they say, well, what's really going on in Blackwell? I don't see nothing happening in Blackwell. Let's talk about that. $23 million bond on a hospital, or on a high school. $17 million brand new hospital that we saved that easily could have disappeared. And Stillwater Medical just signed a 10-year extension on that. Roads, we've done over 4 miles of roads in the last 5 years, 4 miles of water line. You see all these improvements around town. But I had the privilege of talking to Mike Shepard right before he passed, God rest his soul. And he said, Jerry, if you can't see the good things going on in Blackwell, you either A, don't want to see it, or you're just blind. And I'm not here to pitch the city, but the city and this council, because without the mayor and this council, we can't do anything without their support. But you see all these infrastructure upgrades, new LED lights, new sidewalks, new roads, new water lines. It's hard to see infrastructure, and I'll be the first one to tell you that. I can replace every water line, sewer line, electric pole, electric line in town, and most people wouldn't even notice it. Why? Because you drive by it every day. It's supposed to be there, or it's in the ground. There's nothing fancy about infrastructure, but we have to have it. And we're not telling people how to vote. We just put this back on the ballot, hoping for the community's support. And if it doesn't pass, I'll bring it back to the council, and it'll be up to them and myself and Mr. Kennedy and Mr. Wolf over there to find another avenue. So,
This money's going to strictly go to the water plant.
the debt service for the water plant, yes.
What can you do to get it out to the people? Because you can see right here what's happened. Not very many people are showing up.
Well, I'll answer that honestly, because I've been through this before anytime there's a subject like this. Outside of going door to door, I don't know how to help you. It's in the newspaper, it's on social media. We've had 4 public meetings. I don't know what else to do. I don't. I mean, outside of going door to door, and we went through this back when we hosted some events, and I would run into people and they'd be like, man, I didn't know about that. And it always kind of perplexes me, because if it's anything controversial or interesting, everybody knows about it. But when you overload with information, and I know the local community talk page ran this all week as well, outside of forcing people to come here. Now there's another way to look at that. Those subjects have come up before, and people have said, well, why don't people show up? Well, my opinion is the mayor, the council, the councilwoman that are here, those are City of Blackwell's elected officials. If I voted for them and they're up here doing a good job, I got better things to do with my life. I've got ball games to go to. I rarely get to see my wife, so any chance I can catch her, because we work opposite schedules. I'm going to trust these elected officials to make the best decision for Blackwell. And I'm not saying that because I work for them, but I think most people, those are my elected officials. That's my mayor, that's my councilman. I think that's why this room isn't full right now. I could be absolutely wrong, but we've ran this for the last 2 months.
You're going to have one more meeting?
Yes, ma'am, June 10th, same time.
Good.
Now, I could have easily proposed, hey, we don't need to have this tonight. We really didn't get that much of a turnout, but it's important. I don't care if there's one citizen here. We still need to have the meeting. The city's very open. There's nothing to hide here. We want people to be informed. We want people to have the right information. Whenever they choose to vote, that's the beauty of democracy. You can vote for it, you can vote against it, but you don't even have to vote at all. And I know on June 16th, I was just talking to this gentleman right over here. There's a lot going on in Oklahoma on June 16th. You can start at the governor and go all the way down. So totally understand that. But we do appreciate everybody coming. Hopefully you learned something tonight. You left with more information than you had before you walked in. My door's always open. My phone's always on. My email. I haven't had one citizen come in my office since this started to even ask a question. Because I got his report, I can't give it as good as him, but,
The
you know.
walkthroughs on Fridays,
Pardon me?
the walkthroughs that he said he does on
Yes, ma'am.
Fridays, can people just show up, or do you call and make an appointment?
Call and make an appointment, and the gentleman sitting in the front row, Mr. Stevens, and I'm glad you brought that up, man. We've had one tour that we gave last Friday, and that citizen didn't even look at it.
Oh, we got two this Friday.
We do have, I know one called today.
Yeah.
You know, but outside of getting out all the information and offering tours, sir, I don't know what else to do to get people. You know, maybe they, like I said, maybe they just got better things to do. It's Tuesday night, maybe June 10th will be better. We're just coming off a holiday, you know, everybody had to go back to work today, so. Thunder game's on tonight. But like I said, my door is always open. Tracy and I are always available. We'd be more than happy. I would rather you ask a question and be informed than make an uninformed decision. So,
Well, the presentation was very informational. I appreciate what you done. We only live here 6 months out of the year. But what you presented was terrific. People need to know about that. And I don't know how you're going to get it to them.
he's presented that, I think this is the third time Mr. Coe has presented
Yeah.
that. Twice in our council meetings and once week.
People don't get excited for an engineer. I don't know what I need to do. Juggle or something.
Well, you say engineering, people just, you take that on.
Yeah, we're doing this all. I can do that.
Well, if there's no more questions, we'll go ahead and conclude the meeting. But if you have questions, even after today, you want to take a tour, my office is always open. Give us a call. Mr. Stevens, Mr. Coe, we'd be happy to answer any questions. And it's pretty cool if you've never been down there. You're seeing 100 years worth of history, literally.
Where do we call to get to?
7250-363. Just call the city administration office. We'll let Mr. Stevens get your number
Okay.
and set up a time, and we'll make it to where it's convenient for both parties. Other than that, y'all have a great night.
Thank you.
Appreciate y'all coming.